Hey guys, welcome back from the break. We're going to do a little bit of chemistry here, and I'm going to see if I can figure out how to make this program work properly. So before the break, we were talking about molar solubility of compounds, which is the maximum number of moles you can dissolve in a given amount of solvent at a specific temperature. And we also looked at a concept called KSP, which was the solubility product. So I'm going to just do a quick little switching of screens here, and we're going to look at a problem here. So let's say you had silver chloride, and you were told that the KSP for silver chloride is 1.0 times 10 to the minus 10, which is pretty close to the actual KSP at 25 degrees Celsius. But I'm rounding it to make the numbers a bit easier because you may not have calculators. But I'd like you to find the molar solubility of silver chloride based on that KSP. So maybe just pause the video now and calculate that out. Okay, so to find the molar solubility, we need to know that the KSP is equal to the concentration of the ions in solution. So if you were to add silver chloride to some water, it would dissociate into silver ions and chloride ions, and eventually it would reach an equilibrium if it was saturated. And the concentration of those ions would be equal to the molar solubility of the compound. So let's say that X is the molar solubility of silver chloride, then the amount of ions produced for silver ions would be X also, and so would the chlorides. So we would have X times X. We should have written the formula here. Ag plus times chloride. So that would be X squared is equal to 1.0 times 10 to the minus 12. If we square root that, we'll get X equals 1.0 times 10 to the minus 5, actually, because that was supposed to be a 10 there. So that means that there should be this many moles per liter of silver and chloride ions in solution, which is actually the amount of silver chloride that would have dissolved in solution. So the molar solubility of the silver chloride would be 1.0 times 10 to the minus 5 molar. Okay, I'm going to pause the video here and just see how that worked.